Welcome to week 11 of cis204, Unix shell scripting and utilities. And today we're going to continue our discussion of awk. And as soon as I bring this set of slides up, there we are. And where am I? Oh, I'm here. Again, we'll break this down into three parts. And the third part will be kind of entertaining because it's a small discussion of kind of grep, sed, awk, and Perl and Python. We don't touch Perl and Python per se in this class. You will have an opportunity if you continue to program of touching Perl and Python, and hopefully Python more than Perl these days. But it's always good, and one of the things that we've spent a great deal of time in this class on is discussing how all of these things came about. cis204 seems to be almost as much a history class as it is a programming class. Maybe it's because I'm old. But regardless, if you understand where things came from, you have a better idea of how to go forward. If you get thrown into something without any idea of where it came from or how it came to be or the thought processes that the people who created it were going through, you don't have the same level of understanding as you could. And it's neither here nor there. But again, the idea is that as we get into the last piece of this, part 3, we'll get a chance to sit down and look at some commentary on the tools sed, awk, Perl, and Python. And in particular, there's an interesting conversation going on in Stack Overflow on those tools. So, be that as it may, we covered a bit of awk in week 10. We'll finish up our I think we'll come pretty close to finishing up our discussion on awk this week. And we'll have a number of things that we'll end up doing. Without any further ado, cheese is going away. Okay, more awk. Awk. So let's start with a quick review of last week. Awk is a Unix programming language. It's used for manipulating data and generating reports. Remember, this whole thing started because we needed to find a way of convincing management that they needed a bigger machine. And you can't convince management that you need a bigger machine to play a game with, but you can convince management that I need a bigger machine because we're going to do text processing. And it just so happened that everything that was done in the Bell system required a manual. There had to be a Bell system practice written for everything you did, including which way to hold your pencil, which way to write on the line paper, which in the Bell system was always known as blue line. So if you ever hear somebody refer to as they're writing, I'm putting comments on blue line, that's because of the blue lines on the paper. In awk, since it's a program used for manipulating data and generating reports, and man did I go sideways, data can come from standard in or from files. The fun thing is you can issue awk and take data from the terminal, but most of the time you'll see it taking data from a file. So how does awk view the file? Well, it breaks the input stream of the file down into records, the records being a line. It looks for the end of the line. It's a record separator. Now, the fun thing is you can change what the record separator is, but we'll go into that later. It then breaks down the individual records into individual fields. So a record's normally a line, with the familiar new line signaling the end of the line for our purposes. The definitions of records and fields can be modified even during processing, which is kind of entertaining. Awk will use patterns to find data and actions to act on that data. So that'll give us an idea of where we're headed. awk does not see input data as a string of characters. In other words, it's not looking at individual characters. It's looking at fields. So it'll apply a format structure to the input, strings, integers, that type of thing. The usual suspect meta characters that we've been dealing with are available to awk. It uses pattern matching that you've seen in grep and in VI and in sed. So that's available. Matching on any field in a record can be done. In other words, I want to see a specific field on the record. I don't want you to look for something in fields 1, 2, 4, and 5. I want you to look for something in field 3 only. Actions are always Actions are always enclosed within curly braces in awk. If you want to perform an action on a field or a record, you have to enclose it within curly braces. So, remember we talked about field separators and record separators? There are internal variables, and these are restricted. In other words, you would not want to use these as set fs, export fs equals something. These are internal in awk. The fs is the input field separator. The nf will deliver the number of fields for a record. nr will deliver the number of records. rs, or actually, it doesn't return the number of records. It returns the number of the record being read. So I can put a line number in there using the nr with the print function. rs is my record separator. For our purposes, that's going to be a $sign normally. OFS is the output field separator. Interesting. Okay. So, how do we do this? Well, the number of fields in a record does not have to be constant in a file. And the number of fields for a line can be returned using an action to return the number of fields per line. For instance, let's take a look at this particular awk. So, let me do this. We'll paste that in there, and I want to do tilde files outy duty.txt, and we'll pipe that to less. Notice the outy duty.txt file has multiple lines with multiple fields, different field lengths or field numbers inside those individual records. The lines are the records. So if we keep going forward here, you'll see sometimes there's a record that has 42 fields in it. I guarantee you that that one is one of those pieces of text that has no end of line. 13, 12, there's one with 63. So you can see we're not restricted to a set number of fields per record. So how can I set fields? Well, fields can be set using the field name equal field format. An example, the output field separator equals the colon. So if I run this awk OFS in max test, which is in here. So let's take a look at max text. There's max.txt. Okay. Notice what all that has in it. It has two numbers and a name. Sometimes the numbers have are not just integers, they're floating points. So what am I doing here? I want to print 1 and 2 in max.txt, and I want to put the field separator as a T. So let's paste that in there, and let's go fix up these goofy Microsoft quotes. Here we go. And that's exactly what we expected it to do. Now, what happens if we change that from a T to a colon? Works fine. So I've just specified a new output field separator. What was the input field separator? A space. Space is the default input field separator. Okay, well that worked. Cool. So what kind of expressions can we deal with here? Well, there's the usual relational operators. There's less than or equal, not equal, greater than or equal, greater than, match the regular expression. In other words, give me, it doesn't have to be exactly, but it has to contain this. And the not match doesn't match the regular expression. In other words, I don't have anything that contains that regular expression within it. The other thing you can do is you can deal with conditional expressions. So if else, if expression 1, expression 2, else expression 3. So if 1 is greater than 2, then max equal 1, else max equal 2. Well, okay. So what does that do for me? Well, I can compare two fields and determine which one is greater than the other. If 1 is greater than 2, then I set max to equal $1. If field 2 is greater than field 1, I set max equal field 2. Remember, the $1 and the $2 represent the field. Records are lines. Fields are individual strings of characters, either numbers or strings, alphanumeric. Okay, moving forward. So I can do computation. So I can do addition, subtraction, multiplication, division. I can return a modulus, and I can do exponentiation. Now the modulus is, for example, 5 mod 2 equal 1. In other words, 2 gazinta, and that's a great old way of saying division. Gazinta means goes into 5 twice with the remainder. The remainder is the modulus. So I divide 5 by 2, I account for 4 of the 5, and I have a remainder of 1, and that remainder of 1 is the modulus. And then, of course, the caret becomes exponentiation. Logical operators. Yeah, this is looking a lot like C. I've got the double ampersands, the double pipes, and the ball bat. And or not. Now, like said, I can use range patterns to determine exactly where I want awk to work in. So here's an awk statement that says awk, find Tom, and then find Suzanne in whatever file. Now, if I wanted to put an action in there, at the end of that regular expression that I'm matching, that range pattern, I'd have curly braces and then the action. Now, the book uses a data validation routine for etc password, which is kind of interesting. So let me see if we can find this here. Password check. So let's take a look at this password underbar check.awk. So here's a cheap test of the password files. And remember, comments are always welcome. And you'll notice one of the things I do with comments is the last time I touch the file, from an editing standpoint, I'll put in my initials and the date I touched it. So if I run this awk-f password bar check.awk on etc password, does not have 7 fields. Interesting. Look at this. Worked like a champ. Did exactly what I expected it to. Let's look at that file again. So line does not have 7 fields. The line non-alphanumeric user, or there's no password. Notice what I did. So if the number of fields is not equal to 7 And let's do this. Let's more etsy passwd. 1, 2, 3, 4, 5, 6, 7. So where did my process fall down? Would you believe my process fell down because I did not specify what the input field separator was for Etsy password. That's why it returns this does not have 7 fields. We know it works. So let's do a man on awk. It's gawk, as we know. So option format -- field separator. Okay. So let's do this. -f : there are no problems with the password file. Okay, but look what's happening here. So first thing is, check the number of fields, and if it's not equal to 7, print the line, give me a digit. This is going to be substitute digit in the printf, does not have 7 fields, and then substitute a string and a new line. So what am I going to put in here? I'm going to put the number of the record. Okay, so when I had that without that, notice what it did. Line 206 of the password file does not have 7 fields, and then it prints $0. And what's $0 in awk? $0 is the record. $1 is the first field, $2 is the second field, $3 is the third field. Okay, so what happens the next go around here? The next go around says look at $1. So let me do this. Let me find my password. Not password, but my password file entry. So there it is. So what's happening here? If $1, which is H-Becker 3, does not match capital A to Z, lowercase a to Z, 0 through 9. In other words, if it's not alphanumeric, then print the line number, number of record again, non-alphanumeric user ID, and then print a string, which is the record. Cool. Okay. Now, here's a fun one. Something interesting in the password file. Notice in this password entry, I have an X in my second field. The X is an indicator that I have a valid password. The password is no longer stored within the password file. My encrypted password is no longer stored in the password file. It's stored in a shadow password file. And to be honest with you, I'm not even sure I can look at the shadow password file or find it. I think I can probably see it, but I can't view it. The fun thing is it used to be that those passwords existed right in the Etsy password file. You could actually go in and clean out an Etsy password entry and have the user put a new one in and would not have to remember their old one. In this case, if there's a star, an asterisk, or a splat, as I like to say, I would print the line number, no password. The asterisk in that would mean that a password does not exist for that entry, and one needs to be created. Okay, so we're pretty well through part 1, and at this point I'm going to finish this recording and we'll start up with part 3. Talk to you in just a moment.